Alright, you guys, we're looking at lesson 5.6, which is graphing absolute value functions, specifically in vertex form. So the first thing I want to make sure you guys understand is what the parent function of an absolute value is. And that's just what we call the most basic absolute value function we can think of, which is right here. Y equals the absolute value of x, right? Now, if you want to get a visual of what that might look like, you would just plug in some values right here in for x and see what comes out. So I chose some values to put into the table for x for you, so -2, -1, 0, 1, and 2. And what you'll have to do is plug that into the absolute value and see what comes out. So what if I plugged in absolute value of -2, or absolute value of -1, absolute value of 0, absolute value of 1, absolute value of 2? Well, the absolute value of -2 is 2, the absolute value of -1 is 1, absolute value of 0 is 0, absolute value of 1 is 1, and absolute value of 2 is 2. So if you were to plot these points right here on your coordinate plane, -2, -2 would be here, -1, (1) is here, 0, 0 is here, 1, 1 is here, and 2, 2 is here, right? So what you're going to see if you create this graph is it's basically going to make the letter V. And that's a very important thing for us to understand, because whenever we create these absolute value graphs, okay, so whenever I graph an absolute value function, it should always make the letter V. What you'll notice if I really kind of zoom in on this graph here and count out my slope, which is rise and run, you guys will see that if you rise 1, run 1, rise 1, run 1, rise 1, run 1, rise 1, run 1, and it would look more, I think, appropriate if I actually put the rest of these dots where they belong. But if you keep rising 1 and running 1, your slope is going to be 1, and you can do the same thing the other way by going up 1, backwards 1, up 1, backwards 1, up 1, backwards 1, up 1, backwards 1, so on and so forth. So the slope of these graphs is actually at, let me change my pen color, is at 1, but also -1. That's very helpful, because what you'll notice then is the slope of the absolute value graph, I'll call it the V, is always the number in front of the absolute value. So on this specific example, you guys can see right here that my graph happened to have a 1 right in front. Okay, but if there was a 2 there, you would slope differently, and we'll talk about that in a little bit. The next thing that we want to discuss is how can I, look at harder, more complex versions of the vertex form and understand how that affects the V that I create in the absolute value. So if I put y equals, what if I had some additional information besides just the absolute value of x? I could put a number out here. I could put a number inside the absolute value, or I could put a number towards the back, right? So there's these different locations. We call this the A value, we call this the H value, we call this the K value. These are all various locations where we could introduce new numbers that would actually change not the shape necessarily, but kind of the location or the outcome of our graph. So here's how you'll know how to transform your absolute value graph compared to what's given to you by the parent. So the first thing is if your A value is positive, your graph is going to end up opening upwards, which means your V is just going to look like this, just like it did when I just graphed it before. But if your A value were to be negative, this graph would actually open downward, meaning your V would be upside down, and it would look like this, with a vertex here, and one side would go down this way, but the other side would go down that way. And that's if your A value is negative. We'll talk about that in detail a little bit later. If the A value is bigger than 1, like I said, your slope will change, which means your graph will actually either stretch if you have a big A value, or your graph will shrink if you have an A value like between 0 and 1. Okay? And then the H value, which is always going to occur right here on the inside of your absolute value, this will shift your graph either left, so it may shift your graph to the left if you have a positive h value, or it'll shift your graph to the right if you have a negative h value. The last number might appear here behind the absolute value bars. That's called your k value. Your k value is either going to shift your graph up or shift your graph down, depending on whether the k value is positive or negative. So we'll look at a couple and see if we can make some sense of this table. Okay? So it says, where will each of these functions go? Describe how the following functions would be transformed compared to the original parent function. Well, let's take a look at this number 1 first. For number 1, you guys will notice that if I try to compare it to the transformation notation that I just wrote down, basically, for number 1, you would have y equals an a value and then x minus the h value all plus the k value. Well, what you'll notice is in our situation, there is no h value in the problem, there is no k value, but there's absolutely an a value, right? And that a value is 2. So the fact that the a value is 2 means a couple things. First of all, it means that's a 2, not a z. It means my slope is actually 2, right? So the v is going to end up looking a little bit taller. It also means that my graph opens upwards, right? And finally, the vertex, which we're always going to discuss where the vertex goes, your vertex is just going to stay at 0, 0, just the same way that it was in your original parent graph up here. You guys see right here on the original graph that I created how my vertex, I probably need yet another color, maybe like a blue. You see my vertex right here, how it's at 0, 0. Well, it's going to stay at 0, 0 as the vertex unless your graph shifts, like maybe left or up or down. Then you can move it based on where 0, 0 is. But the fact that the slope just changed, that just means that this v, instead of going where the green lines are, up 1 over 1, up 1 over 1, it would actually now go up 2 over 1, up 2 over 1. So you'd have dots here, up 2 over 1, like a dot here, up 2 over 1, a dot here, and so on and so forth. So your v would just change its shape a little bit, that's all. If I look at the next one, number 2, now you'll notice again I can compare that to my parent function, y equals, well, there should be an a, maybe an x minus h in here, and then plus a k at the end. Well, you'll notice on this one now there is no a value because where the a value should be would be right here. That means that the slope is just 1, so nothing really changes there. The slope is just 1. There is no h value because, again, look, there's nothing inside the absolute value. There is, in fact, though, a k value right here, if you notice. So the k value always shifts the graph up or down. Because my k is positive, my whole graph would go up 1 unit. Since the graph went up 1 unit, I would still keep my slope at 1, so I don't have to change anything there. But the vertex is no longer going to be at 0, 0. Since the graph got shifted up 1 unit, the vertex is actually at 0, 1 now. Because think about it, my vertex used to be right here, but now it's actually right here because it got shifted up 1 unit. So think about that vertex. Your slope would still be 1, and I'll show you what that looks like on the graph towards the back. Try number 3. Number 3, I'm not going to copy the vertex equation again because I think we're kind of getting the hang of it, but there's definitely a 1 right in front of here. So your slope is still at 1, that's just fine. There's no h value, but this value back here is the k, which means this moves down 3 units. So when you graph it, your vertex, oops, it's like glitching on me, hold on. The vertex should be at 0, negative 3, because remember, it got moved down 3 units, okay? I'm going to keep moving here. Number 4, this one, maybe I will put the vertex form on, because the parent says y equals, there's an a value out front, x minus h in the middle, and then a plus k out here. Well, you'll notice again, the a value is just 1, so it still opens up like it normally would, and at the same time, you have a slope of 1, so nothing really changes. You do have this h value here, though, for once. This is our first h value. There is no k, otherwise there would be like something back here, right? There is no k value. But the h value is -4, which leads us to believe that this graph is actually going to shift. Whenever the k value is negative, it makes your graph shift to the right however many units it says. So this should go right 4 units, which means if this was my vertex right here, well, now it just went 1, 2, 3, 4 units to the right, which means my new vertex is actually sitting like right here. And then I would slope 1 up and 1 over, which means my v would actually end up looking like this. Like I said, we're going to get to some graphs on the back. I'm just kind of giving you some insight. But my vertex is actually now at, 4 to the right would be 4, 0, like that. Okay? Just look at a couple more on the front here. For this one, your graph would shift. Well, it's a k value, right? Because y equals, there's an a out front, x minus h, and then plus, or sorry, not k value. There is no k value. There'd be something here if there was a k value. There's no a value here because there's just a 1 out front, right? So the only thing there actually is this positive 1, right? There's no k value. The a value is just 1, which doesn't change my slope. So this graph is actually going to shift left 1 unit, which means my vertex is actually at -1, 0, right? This one is one we have not seen yet on number 6, and number 6 looks like you'd have to definitely find the a value, which is up front. Here's the a value at -1, which means two things. First of all, you should think, well, this thing's going to open down because there's a negative in front of the a value, and also the slope is then going to have to go like in reverse order, because if the a value is -1, the slope is actually going to turn into being down 1 over 1, right? You don't have to worry about moving the vertex because there's no k value, which would have moved it side to side, and there's no h value. There's no h value, which would have moved it side to side, and there's no k value, which would have moved it up and down. So in this case, the vertex is actually just at 0, 0 as well. Okay? I'm going to leave 7 and 8 for you guys to do on your own, and then I'm going to look at the back and just try to give you a couple of the graphs. Maybe we'll just do a few of them. Let's look at number 9 first. It says identify the transformation and then graph your absolute value. So for this transformation, you'd want to, again, line it up with what's the slope and is the vertex being shifted at all. Well, if I wrote y equals, there should be an a value and then an x minus, and it's just glitching on me again, x minus h, all plus a k. Well, you'll first of all notice that the a value is 1, so my slope is 1. There is no h value because it would have been inside the absolute value. There is a k value towards the back. The k value is going to move your graph up 1 unit. So do me a favor. Instead of your vertex being at 0, 0, just move it up 1 unit to 0, 1. Put your vertex here. Now just slope whatever the a value is. The a value is 1, so slope rise run of 1, rise run of 1, rise run of 1, and go the other way. Rise, run, rise, run, rise, run. And you should make your nice little V right there. The other thing you guys could do if you absolutely want to is throw a table together. You know, you don't have to, but if you are going to throw a table together, just do me a favor. Please make sure, and I talked about this in class as well, please make sure if you're going to put a table together that this vertex value, 0, 1, goes right in the middle of your table. That's super, super important. I'm even going to put a note, vertex must go in the middle of your table. That is if you're making one. You don't have to, obviously. But if you're going to make a vertex, go in the middle of your table. And then what you can do is just go around the vertex. So like 0, well, I can go 1 higher and 1 lower. And then you guys would just plug it in. It says y equals absolute value of x plus 1. I'll rewrite it. Y equals absolute value of x plus 1. And I'm going to plug in each of the numbers that I was supposed to. I tried right here, I put a 1 in for the table. right here, I put a negative 1 in for the table. And just see what each equals. Well, the top one would say that, let's see, if absolute value of 1 plus 1 would just get you 2, which you'll notice 1 comma 2 is actually already on your graph. It's right here. The vertex 0, 1 is already on there as well. And then the other one would say absolute value of negative 1, which is 1 anyways. And then if you added it, you'd get a 2. So 1 comma 2 is on your graph as well. You can find that right here. Right, so it ends up working with the table anyways. You could make more points, plug in 2 to the table, plug in 3 to the table. You're going to create that V anyways. Okay. Try maybe just a couple more here. Let's do a difficult one. Let's do number 14. I think there's a lot going on number 14. Try number 14. So for number 14, it looks like you have actually 2 movements. You do have an a value of 1 out front, which means you're going to slope by 1. But you'll notice this, if I wrote y equals a value of 1, x minus h, all plus a k, you guys will notice you have an h value of positive 2 and a k value of negative 3. Now, if you think about how that might move your graph, hopefully you're understanding that you're moving your graph left by 2 units. That's because of this here. But you're also moving it down 3 units because of that k value there. So if I were to move my vertex, which was at 0, 0, always, if I move it left 2 units and then down 3 units, your vertex is actually going to end up at negative 2, negative 3, which would be 1, 2, 1, 2, 3, right here. And then you could slope by the a value, which is right here. A value is 1. Rise, run, rise, run, rise, run, rise, run, rise, run, and backwards. Rise, run, rise, run, rise, run. So you'll see you get a nice constant V, which is exactly what your graph should look like. Now, if you don't like that and you need the table for reassurance, you could make one, don't forget. So you would just come over here and pick some X's, find out the Y's, but the key is this vertex has to go negative 2, negative 3, right in the middle. Has to go in the middle. And then you can build around it, right? I could choose like negative 3, negative 4, some of those negative 5, negative 6, so on and so forth. If you go backwards, try like negative 1, 0, all those. So I'll plug them in. Let's see. Absolute value of, I'll just use 0 as an easy one. So y equals absolute value of 0 plus a 2, all minus a 3. Well, that means y would be absolute value of 2 minus a 3. So y would be, absolute value of a 2 is just 2 anyways, minus 3. So y would be like negative 1. So I'm going to put a negative 1 right here. Check if that's on your graph. Is 0, negative 1 on your graph? Yeah, it's actually right there, 0, negative 1. And you guys could keep doing this. I promise you, if you keep plugging in all these values right, let me clean this up real quick for you guys. If you plug all these x values that you pick into your table, so like 0, negative 1, negative 3, negative 4, start plugging them all in right here. I promise you're going to create this point, and you already have this point on the graph. You'll create this point, you'll create this point, and you'll keep going. And I promise you it'll match, okay? Let me just try one more, and then you guys can maybe practice on your own. 16, I think, is definitely a tough one. 16. So the first thing you guys will notice about 16 is that it does not actually move its vertex, right? Sorry, I'm just trying to get my pen here. It does not move the vertex because there's no side-to-side shift, there's no H, there's no up and down shift, there's no K. So what you'll notice is the vertex should actually stay at 0, 0, right there. What does change is this A value, your slope. Your slope is actually at negative 1/2 because the slope always comes right before the absolute value. I told you guys that earlier. So if your slope is negative 1, you'll also notice the fact that there's a negative right here. This graph, and I'm going to put a note here, this graph should open down. So the slope is rise. Well, the slope is negative 1/2, which means rise over run, but it has to open down. So do me a favor. Rise down 1, run 1, 2. Put a dot here. Rise down 1, run 1, 2. Put a dot here. Now do the same thing the other way. Rise down, run 1, 2. Put a dot here. Rise down, run 1, 2. Put a dot here. Right? And so once you kind of continue along this pattern, let me clean up all my slopes, you should get a line that looks like this. And then again, if you want, go ahead and make your table. The only thing I would encourage you for this table right here, do me a favor and stick your vertex right in the middle. So you'd put 0, 0 right here. And then you'd build some points around it. So go up a couple, like 1, 2, go down a couple, -1, -2. You'll find that if you plug them in, you'll get these exact dots. If you plug all of these x values in right here, and plug these in here, and plug these in here, all into that x value, you will definitely get the dots that I created on the graph. Okay? So I think that should be good. As usual, let me know if you guys have any questions, okay?